Haryana Urban Development Authority has constructed a 120 mld capacity main pumping station, and sewage treatment plant, along with tertiary treatment plant at Behrampur, Gurugram. It is based on SBR technology. The plant is taken over by Gurugram Metropolitan Development Authority. The STP receives the flow from last manhole of sewer line of 2000 mm diameter. A pipe is provided to receive the flow of 120 mld to the inlet chamber. Raw sewage from the inlet chamber enters into the course screen for removal of floating debris. 4 parallel channels are provided with 2 each being allotted to mechanical and manual course screen. After course screening, raw sewage enters the sewage sump, which is designed on the basis of peak flow with hydraulic detention time of 5 minutes. Stilling chamber is provided at a higher ground level to receive raw sewage from the pumping station. Its purpose is to dampen the velocity of sewage. After stilling chamber, sewage enters into the screen channel with 5 parallel channels, with 3 being used for mechanical screen while 2 for manual fine screen. Mechanical fine screen is controlled by level transmitter provided into the screen channel. After fine screening, the sewage flows to the grit separator chamber under gravity for separation of fine grit inorganic particles. Grit chamber is constituted with grit scraper mechanism for grit collection, reciprocating rake mechanism for grit removal, an organic return pump for recycling of organic matter into the grit chamber. The flow from the grit chamber is collected in the distribution chamber. 4 clarifiers are provided with maximum surface loading rate of 32 meters cubed per day at average flow. The underflow sludge consistency level of 2 to 3% is then passed on to the combined sludge sump by gravity. The collection chamber is provided to collect the supernatant from the primary clarifier, as well as to forward the effluents for biological treatment. Biological treatment unit comprises of C-Tech SBR reactors. The primary treated sewage is taken into one circular unit. Total 60 minutes of filling time is provided for the cycle, in which sewage is filled into the SBR basin for biological treatment. 90 minutes of aeration time is provided for degradation of microorganism into the SBR basin along with filling cycle. 61 minutes of settling time is provided for this cycle. In this cycle, all mixed SBR sludge is settled into the bottom of the SBR basin, and supernatant treated sewage remains till the last level of decanters. 63 minutes of decanting cycle is provided for treated sewage from the SBR basin to the outlet of the tank till the decanting level of SBR basin reaches 2 meters. The treated sewage from the C-Tech basins is further taken to chlorine contact tank CCT for disinfection, by using chlorination dosing at a rate of 5 mg liter. Out of 120 mld sewage, 25% sewage is taken for tertiary treatment, for recycling and reuse of sewage water in textile industries and horticulture. Flocculation unit receives water from the central shaft. The unit is also provided with mechanical pedals. Underlow sludge of the clariflocculator is collected in the sump, and is further pumped to the inlet of SBR tank. After the clariflocculator unit, the sewage enters the filter bed, with a constant head and constant flow type. Total 4 filter medias are provided for 30 mld sewage filtration with maximum filtration rate. After the above filtration, further disinfection is done by using chlorine gas at another CCT. Sludge generated from the primary clarifier and biological treatment unit is collected into the combined sludge sump. A thickened sludge of 5% consistency is fed to the anaerobic digester, in order to reduce putrescibility. Belt filter press house accommodates the belt filter press unit with sufficient floor height. DWPE dosing is done with a dosing rate of 2 kg per mt of dry sludge. The biogas produced during anaerobic digestion is primarily comprised of methane and carbon dioxide, with smaller amounts of hydrogen sulfide and ammonia. After water wash, gas is compressed by root blowers and passes through the chiller unit, where all the moisture present in the gas is converted to water, and dry gas is fed into the biogas engine. 2 biogas engines are provided for the consumption of biogas. One should work with environment responsibility, with a goal to reuse the past, recycle the present, and save the future.